Namaste and good afternoon. This presentation covers generating multi-objective fronts from stream data using a nested list structure. The work is co-authored by Anami Mukherjee, Saurabh Mandal and Professor Paramata Datta from the Department of Computer and System Sciences, Vishwabharathi, Shantiniketan, India. Over the 2 decades, NSG2 and NSG3 have excelled in multi-objective optimization with non-dominant sorting as a key phase. Algorithms like FNDS, ENSBS, and ENSSS handle static data efficiently but struggle with stream data. The proposed approach addresses this gap for online data. Our research addresses key gaps in non-dominant sorting. Most algorithms focus on static data with limited strategies for complex online data. We propose a straightforward yet effective technique using a simple linear structure to manage online scenarios. Cases and method of multi-objective non-dominant sorting using a nested list structure. Case 1 is straightforward. If no elements or fronts exist, the first front is created and the incoming element I is placed in it. Case 2, if the incoming element is indifferent to all elements in a front, it is added to that front. Case 3 occurs when the incoming element dominates all elements in an existing front. A new front is created before the current front, placing the incoming element there. The existing front is then reindexed as I plus 1 if it was previously I. Case 4, if the incoming element dominates some elements in front I, it is placed in front I. The dominated elements move to a queue and their correct positions are iteratively determined. Case 5, if the incoming element is dominated by elements in front I, it moves to front I plus 1 and checks for its correct position. Scan this QR code for access to the dataset code and flow diagram. Feel free to visit and cite our work if useful. Here are the methods with their time and space complexities. Finally, our mechanism performs well with the best case time complexity of order of mn for large n, order of m when n equals to 2 and order of 1 when n equals to 1. The worst case time complexity and space complexity both are order of mn. Here m stands for number of objective functions and n stands for population size. Here is the dataset specification. We get the number of fronts and number of elements on those particular fronts exactly same as the FNDS. This work introduces a novel approach for online multi-objective datasets with a best case time complexity order of m and worst case order of mn square using a simple linear structure, though it lacks computational efficiency. These are some of the important references one may look into if they are interested, including a work on the same problem we previously worked on. Finally, thank you very much for your patient hearing of our presentation.